Hi, this video is regarding the last quiz you took, quiz 6. I just wanted to remind you of a couple of antiderivatives that we learned in class. I'm not going to do the whole quiz because all the solutions are in Newton. I'm just going to show you a couple antiderivative formulas that you may have forgotten or may have been confused about. So the first one I want to remind you of is the antiderivative formula that we learned for the reciprocal function 1 over x. We learned that the antiderivative of 1 over x was the natural log of the absolute value of x plus an arbitrary constant. And so I want to remind you of how we did that. So we did it by differentiating the natural log of the absolute value of x. And we differentiated that using a piecewise definition of the natural log of the absolute value of x. So the derivative is going to be the derivative of the natural log of the opposite of x when x is a negative number. And it's going to be the derivative of the natural log of x if x is a positive number. So notice it's differentiable. It's defined for all x except x equals 0. So now let's differentiate. The first piece can be differentiated using the derivative of the natural log and the chain rule. We get 1 over negative x times the derivative of negative x, which is negative 1. So that's for all negative numbers. And for positive x, it's just 1 over x. So notice that when we simplify the first one, that just simplifies to 1 over x. So this means that the derivative of the natural log of the absolute value of x is just 1 over x for all x in the domain. So that means that the antiderivative of 1 over x, or the general antiderivative of 1 over x, has to be the function natural log of the absolute value of x plus c. And that arbitrary constant is absolutely necessary in all antiderivatives. The only time you wouldn't write it is when Newton tells you not to include it in your answer when you submit an answer in Newton. And unfortunately, Newton does that so frequently that I think some students were confused on the quiz and left it off on the first problem and got 0 credit. So I'm giving people back a half a point out of 1 point on that problem if that was the only mistake. You won't see that half a point added in the Canvas gradebook because Newton will just override it. So it's in my offline gradebook. But anyway, so let's look at that first problem in Newton. So notice it says given that s of x is equal to negative 9 over x plus 9 plus 7 over x minus 2, what is the antiderivative of s of x? And it does not say do not include the constant c in your answer. So we will have to include an arbitrary constant in our antiderivative in the final answer. So let's use the formula we just derived. We have 2 reciprocals. We have negative 9 times 1 over x plus 9, and we have positive 7 times 1 over x minus 2. So we're going to use it twice. So the antiderivative is going to be negative 9 times the natural log of the absolute value of x plus 9 plus some arbitrary constant. And I'm calling it C1 because I'm going to have another one for the second term. So the second one is 7 times the natural log of the absolute value of x minus 2 plus an arbitrary constant, C2. The reason I'm using C1 and C2 is because if I use C for both of them, that sort of implies that they're the same number, and they are not the same number. They don't have to be the same number. They could be, but they don't have to be. Each antiderivative gets some arbitrary constant added to it. And so now to simplify this, I would combine the 2 arbitrary constants because some arbitrary real number plus another arbitrary real number is just another arbitrary real number. So My final answer for the antiderivative would be negative 9 times the natural log of the absolute value of x plus 9 plus 7 times the natural log of the absolute value of x minus 2 plus c. However, before I enter anything into Newton, I'm going to check my answer. Don't rush. Just check your answers. So let's check by differentiating. So s prime is going to be the derivative of all that stuff, negative 9 times the natural log of the absolute value of x plus 9 plus 7 times natural log of the absolute value of x minus 2 plus c. And so when I differentiate, remember the derivative, we just derived it. The derivative of the natural log of an absolute value of something is just 1 over that something, right? So we don't have to worry about defining it as a piecewise function. We've already done that. So differentiating, I get negative 9 times 1 over x plus 9 plus 7 times 1 over x minus 2 plus the derivative of that constant, which is 0. And simplifying, I get negative 9 over x plus 9 plus 7 over x minus 2. And that's what we were given for little s of x. So we got the right answer. So what we're going to enter in Newton is negative 9 times the natural log of absolute value of x plus 9 plus 7 times natural log of the absolute value of x minus 2 plus c. All right. And now the other question I want to go over a little bit is the last question in the quiz. It was more complicated, but you were asked for the antiderivative of little h of x equals negative 5 times cosine of x minus 9 plus 5 over x minus 6 minus 5 sine of x plus 2. But here it does say do not include the constant c in your answer. So we're going to have to leave that off when we put it into Newton. But otherwise we would not leave that off. On any written test or quiz, you would not leave that off. It's not optional. So I just want to remind you, so there's 3 terms here, so we're going to use 3 antiderivatives and add them together. But the middle one, 5 over x minus 6, that's just the reciprocal, antiderivative of the reciprocal function. So that one is going to be 5 times the natural log of the absolute value of x minus 6. The other 2 are trig functions, so let's just remind ourselves of those antiderivatives. So the derivative of sine of x is cosine of x, and that tells us that the antiderivative, or general antiderivative, of the cosine of x has to be sine of x plus c. And the other one is the derivative of the cosine of x is negative sine of x. So that tells us the general antiderivative of negative sine of x has to be cosine of x plus c. And these are different c's, obviously. So now let's put it all together. The 3 different antiderivative formulas, we'll put them all together. So the general antiderivative of little h of x is going to be, I'm going to call it big H of x. It's going to be negative 5 times sine of x minus 9 plus c1 plus 5 times natural log of the absolute value of x minus 6 plus c2 plus cosine of x plus 2 plus c3. They each get their own antiderivative. And now when we combine all those antiderivatives, they each get their own arbitrary constant. So when we combine all those arbitrary constants, we just get another arbitrary constant. So I'm just rewriting it with one arbitrary constant plus c. Now before I enter anything into Newton, I'm going to check my answer. I want to make sure I did everything correctly. I only get 2 shots at this quiz. So I'm going to differentiate my answer. So h prime of x is the derivative of that function I got, negative 5 sine of x minus 9 plus 5 natural log of absolute value of x minus 6 plus cosine of x plus 2 plus c. So term by term, I get negative 5 times cosine of x minus 9 plus 5 times 1 over x minus 6 minus sine of x plus 2 plus 0. So whenever you're differentiating the natural log of the absolute value of something, you don't have to go through that whole piecewise thing anymore. We've just done it once, and so we know from now on when we differentiate natural log of absolute value of x minus 6 or whatever, you just get the reciprocal. All right, so our final answer here for the derivative looks just like little h of x, so we did it correctly, and our final answer for the antiderivative is big H of x is a negative 5 sine of x minus 9 plus 5 natural log of absolute value of x minus 6 plus cosine of x plus 2 plus c. However, we remember Newton says, oh, don't include that plus c in your answer when you enter it, and we're also not going to include h of x equals. So Newton says just answer that part, or just submit that part of our answer. So that's what you would submit in Newton. All right, I hope this clears up any confusion, and I apologize for that confusion. Please let me know if you're still confused about any other part of your quiz. Have a great weekend.